Hello guys. Good morning. Can you hear me? Can you hear me? Hello?
Yes.
All right, sounds good. Yeah. All right. Look like we have not enough people in the chat room. Also, we basically today is going to be very short. Basically, so if you don't have a question, I have a presentation and overview of what we learned in past few weeks. So I can basically go through that. This is a short presentation. So we just go through the equations which we learned in past few weeks, and then we call it off. So first of all, do you have any question? Okay, one more time. I wanna emphasize that tomorrow, I think. Let me share my screen first. Share my screen. All right. Can you see my screen? Let me just share it again. Do you see my screen, guys? Do you see my PowerPoint? The PowerPoint? Okay, so you see the PowerPoint, right? So, yes? Shakura, do you see my PowerPoint? Yes, all right, sounds good. Okay. All right, so, okay, let's see when is your lab. So lab and test. So, okay, so the test is gonna be test number 2, which is basically, let me just view you guys as a student. So test number 2, tomorrow is going to be a deadline, guys. Tomorrow at 11:59 Toronto time, right? Eastern time. So just make sure you finish your test 2 before you run out of time, right? And also lab 7 is going to be, you still have a few days, but lab 6 is already done. So just make sure you basically do the test 2, guys, is important. And tomorrow is going to be your deadline. So so today is mostly question and answers. So I was hoping that you guys come up with some questions, and then we can go through your question. But if you don't have any question, I have a short presentation about what we learned in past 4 weeks. I can present that, and it takes not about an hour or maybe less, and then we call it off. So any question before I jump on the presentation? Any question? You're good? I know, Masa, you send me an email, so I appreciate if you can finish the test, try the test. I hope the internet should be fine. If the internet, you still have problem with internet, let me know, and then I will try to extend the time for the test for you. Okay. I receive your email. I understand your situation, but if you find if you can't do the test, that would be great. If not, then I will extend the time for the test for you. Okay. Any other question, guys? All right, I'm just gonna share my presentation then. All right. Okay, so do you see my presentation? Can you say yes, no? Yink, yes? Do you see my presentation now? It's in full screen.
Yes.
Yes? All right, because I don't hear you guys. So when I don't hear you, okay. So all right, sounds good. Okay, so all right, so so what we learned in the past 4 weeks, we learned annuity, right? So what we start past 4 weeks with annuity. So we learn annuity and notation of type of annuity. So what's annuity again? Is just like car payment, mortgage payment, any series of payments made at a regular interval time called annuity. Okay. usually the payments are in equal amounts as well. So equal amounts payments done at the regular interval of time called annuity. Okay, like mortgage payment, car payments, any kind of payment. So and the notations for the annuity, we have T is the term of the annuity, PMT is the amount of the periodic payment of annuity, N is the total number of payment during the term of annuity, J is the nominal interest rate for the annuity, M is the compounding frequency for that nominal interest rate, I is a periodic interest rate for that interest rate. Basically, if J divided by M is going to be I. Payment interval is going to be like payment period, or payment period is the interval between two successive payments. Future value is going to be the accumulated value of future value annuity. So in this case, for the case of future value, your annuity is going to be an investment, right? So if you do an investment, you basically put money in the bank for like $1,000 a month for like 4 years, 5 years, and you want to know how much you have at the end of 4 years and 5 years. It's going to be future value, right? So investments are always future value. Loans are always present value. Okay, present value is going to be the discounted value of present value annuity. Present value, basically, you get the loan and you want to pay it back with the annuity. You want to pay it back $500 a month, $300 a month, right? So for 2 years, 3 years. So that's basically present value. The present value is a loan, and future value is investment. Okay. Future value, you want to know how much you accumulate over time of annuity. Present value, you want to know how much you borrow at the first place, and you want to pay it off. Okay. That's the difference between the two guys. Okay. So we learned a lot about annuity. We know there are two type of annuities: ordinary annuity and due annuity. Ordinary annuity is payments made at the end of each month, of each payment period, and due annuity payments are made at the beginning of each payment period. And also we have ordinary simple and ordinary general annuity. Ordinary simple annuity is compounding a period for the interest rate is the same as payment period. Okay. So if you compounding period for your interest rate is going to be the same as payment period, then it's going to be ordinary simple annuity. So ordinary if it's and simple means compounding period and payment period are the same. Okay. General annuity compounding period is not the same as a payment period. So compounding the period is different than the payment period. It's going to be general annuity. For annuity due as well. So we have payment done as beginning of the period. Simple due annuity is going to be compounding period the same as payment period, and general due annuity is compounding period different than the payment period. Okay, so it's going to be 4 type of annuity. So anytime you get a question, you have to figure out which kind of annuity it is, and based on that you have to go forward. Okay, that's important. So future value for an ordinary simple annuity, the equation is like this. Future value is going to be PMT, the payment per month, 1 plus I power of n minus 1 divided by I. I is going to be periodic interest rate, n is going to be number of payment. Okay, total number of payment for annuity. Okay, so that's going to be future value. Which of the following statement best describe an ordinary simple annuity? So let's go through each of these guys. Okay, payments are made at the end of the period, and the compounding period is different is different from the payment period. So at the end of the period means it's ordinary. Compounding period is different than payment period means that's general, ordinary general, right? So this is not ordinary simple. Payments are made at B. Payments are made at the beginning of the period. It's going to be due. And the compounding period is the same. So due simple. This is going to be due simple annuity, not ordinary simple. C, payments are made at the end of the period, which is going to be ordinary, and the compounding period is the same as payment period. So it's going to be ordinary simple annuity. So it's going to be this one, C. Okay. And D, payments are made at the beginning of the period. It's going to be due, and the compounding period is different than the payment period. So it's going to do general annuity, right? So make sure if in a question they don't tell you whether it's end and the beginning of the period, you always presume it's going to be end. Okay, unless they specifically stated that the payment is done at the beginning of the period, then you presume it's going to be you presume it's going to be due annuity. Okay. using financial calculator. Just make sure that you know how to use the financial calculator for this. I'm just going to bring my financial calculator here. First of all, let's see who's in the lobby. So yes, we got some people in the lobby. All right, so financial calculator. Let me go to financial calculator. Okay, so financial calculator. Okay, so you know how it works, right? So you can set to begin, or so you can set to end and begin. Yeah, right. So you go second. Yeah, let me just do that. You do okay, second query. So you go second PMT. It's going to give you begin. Then now you can change it to end or begin. So it's going to be do annuity, ordinary annuity, do annuity, ordinary annuity, do annuity, ordinary annuity, do annuity, ordinary annuity. Okay, do annuity, ordinary annuity. Okay, and then you can quit. Okay, when you quit, when there is nothing showing on your calculator, it means is ordinary annuity. When it shows begin on top of your calculator, BGN, means that's a do annuity. You're calculating based on do annuity. Okay, make sure you don't forget this, guys. Okay, if it's begin or end. Okay, when it's end, there is nothing show up in your calculator. When it's begin, it shows BGN on your calculator. Okay, make sure. And now you can proceed with all the stuff which we learned. So you have interest rate, you have number of payment, you have payment. You can find present value, you can find future value. You can play with P over Y and C over Y as well. P over Y, C over Y, and then you can find basically your future value or present value. So we solve a lot of questions on this. So I don't want to go back to that. Okay. Unless you have question. Okay. For example, here, let's do an example here. Rick invested $360 at the let me just okay. So Rick invested $360 at the end of every month for 12 years. In an RSP, assuming that the interest rate is 7.74% compounded monthly over the 12 years period. Calculate the accumulated value of his investment. Okay. So $360. Let's do a calculation. Calculator $360 every month for 12 years in RSP. So that's going to be future value, right? Because put on RSP and it just as an investment, right? So okay, so there's going to be basically future value. So which kind of annuity is his first? End of every month, so ordinary annuity. Okay, and is it general or simple? Compounded monthly, 7.5% compounded monthly, and he spent every month, right? So it's going to be ordinary simple annuity, right? Ordinary simple annuity. Let's get back to calculator. Now this shouldn't be begin, then actually end. So let's set it to end, quit, okay. And now $360 as a payment, $360 as sure the payments are negative, okay, payment. And every month for 12 years, so 12 months by 12 years, 144 as a number of payments. 7.5% compounded monthly, 7.5% I over Y, and now we need to go to C over Y, P over Y, right? So number of payment per year is going to be 12, right? It's because it's monthly, 12, and C over Y is going to be 12 as well because compounded monthly, right? So compounded frequency is going to be 12, right? So and then quit, and now we want to know, and the present value is 0, right? Because we want to know what's the future value, right? So CPT future value is going to be 83,676. Yeah. So that's how we do the financial calculator. Okay. Any question? All right. So what's the present value of the ordinary simple annuity? Present value, as we said, is PMT 1 minus 1 plus I power of minus n divided by I. So that's how we calculate the present value for ordinary simple annuity. PMT is going to be payment, I is going to be interest, periodic interest rate, n is going to be net total number of payment. Okay. And now if you have a general annuity, so the most important thing when you see a general annuity, you have to find I2, right? So I2 is, as soon as you see a general annuity, you have to calculate I2 before you do anything else. Okay, I2 is the most important thing you want to do. Okay, I2, you have to find I2 first. Okay, I2 is going to be 1 plus I power of C minus 1. And I is basically is going to be the periodic interest rate, and C is going to be basically compounding frequency for the interest rate divided by number of payment per year. So compounding, if compounding frequency for interest rate is going to be C is equal to number of payment per year, C is going to be 1 and I2 is going to be I, right? So it's going to be simple annuity, right? But if it's general annuity, I2 is different than I. Why? Because the compounding frequency for interest rate is different than a number of payment per year. So that's why you get different I2. And after if you find I2, then you can use that I2 to find future value and present value for ordinary general annuity. Okay. So for due annuity, we have the future value for due annuity is going to be the same equation for general for simple ordinary annuity, but the factor of 1 plus I. Okay, so the factor of 1 plus I is going to be multiplied by whatever you have as basically future value for ordinary simple annuity. Okay, and basically for present value of ordinary general annuity, it's going to be sorry, for due annuity, due simple annuity, basically it's going to be the same equation for ordinary simple annuity with the factor of 1 plus I. So present value and future value has only a factor of 1 plus I in addition of what you have for the ordinary simple. Okay, so due simple annuity has the factor of 1 plus I. Okay, and if you're working with the due general annuity, you need to calculate I2 first. I2 first, which is 1 plus I power of C minus 1, and C is going to be again compounding frequency divided by number of payment per year, and then use I2 to find future value and present value for due annuity. Okay, that's the only difference. Any question? Any questions so far? All right, no question. Let's go to how to calculate payment. So basically payment, so in some question they give you PV, they give you I, they give you N, and they ask you for payments. So that's how you calculate the PM. You have to isolate PMT in this equation. Also for present value and present value due, sometimes it's going to be due annuity, sometimes it's going to be ordinary annuity. So basically you can isolate for a payment and find basically the payment. Okay, and also so calculating also the N, the number of payments is going to be basically how do you calculate? So the number of payments. Okay, so for the number of payments we have 4 different categories, right? So it's going to be ordinary annuity, ordinary simple, ordinary and due. So you got, okay, so you have 4 different kind of things, right? You have present value and future value. You might have, or basically ordinary annuity and due annuity. Okay, so like 4 different cases for N, the number of payments. So 4 different cases, as I said, it's going to be future value or present value, or ordinary annuity or due annuity. Okay, so you have 4 different equations. Okay, so it's going to be future value for ordinary annuity, right? So it's going to be N is going to be ln 1 plus I multiplied FV divided by PMT ln 1 plus I. And if basically it's general, ordinary, if it's general, then you have to replace I by I2. Okay, but still you have to use the same equation. Okay, so that means that that's ordinary annuity. Okay, if you have future value. If you have present value for ordinary annuity, N is going to be minus N1 minus I multiplied PV divided PMT divided by ln 1 plus I. And if in that case, if this is ordinary, right? We're talking about ordinary annuity. Okay, can be general annuity, ordinary general. If it's ordinary general, then you replace I by I2. Okay, so N, you had 4 different cases, right? So you have future value, present value. And also we have future value due annuity. And also, okay, so after we find n, we can basically find t n divided by number of payments per year. Okay, so also we can have future value due annuity and present value due annuity, and then we can find n with that as well, right? So n is going to be, for future value due, is going to be ln 1 plus I multiplied by fv due divided by pmt 1 plus I divided by ln plus y. As I said, it's just, if it's due general, then you have to use I2 instead of I, okay? And if for present value due, basically you have to use this equation. So n is going to be this, okay? 1 minus ln 1 minus I multiplied pv due divided by pmt 1 plus I divided by ln plus 1 plus I, okay? So that's basically if you're working with the present value due annuity, okay? And you have to replace I by I2 if it's general annuity, okay? So these are all the equations which we learned in past 4 weeks. These are all the equations which we learned past 4 weeks. So if you don't have any question, we might go to have some examples, solve some examples together. So because that went very fast, I thought it's going to be longer than that. So we can solve some questions together. Okay. Okay, let me just open another PowerPoint here. Okay. Let me close that guy. All right, so all right, we discussed this. We solved this problem. All right, let's do some examples. Okay, so Nick purchased an annuity that provides him with the payment of 1,650 every month for 18 years at 16% compounded monthly. How much did he pay for the annuity? Okay. All right. He purchased an annuity, okay, that give him this monthly for many years, okay? So it means he bought something at the beginning, and now he's getting money out of it until it's finished, right? So that's the present value problem, right, guys? It's very important to know which kind of problem you're working with. Is that present value problem or a future value problem? He purchased something and now he's getting paid out of it for 18 years. Okay, so it's not that he's saving money for 18 years. He purchased something that provides him with payment of this for 18 years. Okay, so that means that's a present value problem. There is a loan, there is something that he has, and he's getting money out of it. Okay, so it's a present value problem. Okay, which kind of annuity it is? It's every month, which means end of every month, because it doesn't say end or beginning. It means end of every month. So it's going to be ordinary. It's going to be ordinary annuity, and which is it simple or is it general? It's simple, right? Because 8.16% compounded monthly. So it's monthly payment, and is interest rate is monthly, right? So it's going to be simple ordinary annuity. Okay, so let's go back to calculator and do it in calculator. Let me just go to calculator here. Let me clear everything. Oops. Let me clear everything. Okay, clear. And now, okay, so now payment of 1650 negative sign PMT. Okay. Every month for 18 years. 18 multiplied by 12 is going to be the number of payment, right? 18 multiplied by 12 is going to be number of payment, and okay, 18 months, 18 years every month, right? So it's going to be that's going to be number of payments. 8.16% compounded monthly, 8.16 compounded monthly. And now future value is going to be 0 because we are working with the present value, right? So we have 0, it's going to be working with present value. We want to know what's the present value. And now we have to go to P over Y1, or P over Y, C over Y. P over Y is going to be 12, right? It's 12 payment per year, right? every month, okay? And C over Y is going to be the same as P over Y, right? Because the interest rate component monthly, right? So C over Y is going to component frequency is going to be this. Go out, second, now we work in present value. Oops, I'm so sorry. What did I do? Sorry, okay, quit. Yeah, so CPT PV, 185,600, whatever, right? So I said, okay. Any question here? All right. We learned this. Now let's do another example. Lily saved $250 every month in an account that was earning 6% compound quarterly for 2 years. What was the accumulated value of her investment at the end of the term? Okay, $250 every month in an account. So first of all, which kind of annuity it is? Every month means end of every month, right? So it's going to be ordinary. It's 6% compounded quarterly, right? It's compounded every 3 months, but she's saving every month, right? So the compounding period is different than the payment period. So it means that's general, right? So it's general annuity, ordinary general annuity, right? So it's going to be ordinary general annuity. So as I said here, so basically we need to basically find what was the accumulated value of her investment at the end of the term. Okay, so we're working for the future value, right? Accumulated value. So you're working future value for ordinary general annuity. Okay, so let's go to calculator. Do it in calculator, much easier than the equations. Let me clear everything again. See, calculator are make life much easier, right? 250 every month, 250 negative sign payment every month. 6% compounded quarterly, 6% I over Y. The total number of payment every month for 2 years, right? Every month for 2 years. So 12 by 2 is going to be 24. The payment is going to be 24. And then what else we want to set here? We want to set, so present value is 0 because we want to know what's the future value, right? So present value is 0. We start to accumulate from 0. And now we want to go to C over Y, P over Y, right? P over Y, payment per year, 12 payment per year, right? 12 payment per year. So it's going to be 12. But compounding frequency for interest rate is going to be 4, right? So we got every 3 months, right? It's 4. 4 is going to be compounding frequency for interest rate. So quit. CPT future value, 6,356, okay? Yeah, 6,356, okay? Calculator, that's what we do with the calculator, 6,356, okay? So using calculator is much easier than using the equations. Yes, I know that. So it's not cheating. So you use calculator have everything hardwired in it. So if you're comfortable using calculator, that would be great. If you have time, you might want to use equations and papers to double check your answer in calculator, okay? If you have time for the test, okay? But if you don't have time for the test, you can use the calculator. But it has always a risk that you do some a sign or wrong or something wrong, and your result wouldn't be right. So yeah, there's always risk, but it's up to you guys. You can also use the pen and paper and the formula sheet, okay? All right, any question until now? No question? All right, let's go to next example. Martha made contribution of $350 at the beginning of every 6 months. Beginning, guys, right? Beginning means it's due annuity, okay? So make sure you set your calculator on begin mode, right? Immediately when you say begin, you have to set your calculator in begin mode, okay? So let's do that right now. Let's go to calculator, make it begin and come out, okay? So make sure that you don't miss that, okay? $350 beginning of every 6 months for 8 years toward the RSP. If RSP earns this component semi-annually, what will be the value of RSP at the end of the time period? Okay. Okay. So this is the future value problem, right? Because save money and the RSP, and want to know what's going to be RSP value at the end of the year, right? So that's going to be future value problem. Which kind of annuity it is? So let's see, beginning. So it's going to be due and every 6 months, semi-annual. So every 6 months is going to pay. Interest rate is 5.6% compounded semi-annually, right? So it's going to be every 6 months. So it's going to do simple annuity. Do, which is beginning. Simple means every 6 months and compounded semi-annually, right? Do simple annuity. Yeah, simple annuity do. So let's go to calculators, calculate the RRSP. All right, so let's first of all clear everything, guys. Make sure you clear everything, okay? First clear everything, okay? Make sure that BGN is set up in your calculator. BGN, right? So beginning, okay? Beginning, okay? Set up $350, 350 bucks negative payment. Yeah. Every 6 months for 8 years. 8 years multiplied by 2, right? Every 6 months. Number of payment per year is going to be 2. Multiplied by 8 is going to be 16. So 16 is going to be N, okay? And then 5.6% component. 5.6% is going to be your I over Y. And now what else we have to set? We have to set present value as 0, right? Yeah. And now we have to go to P over Y, C over Y, right? So P over Y, payment per year, it's going to 2 payment per year, right? 2 payment per year. And component frequency per year, component frequency is going to be 2 as well, right? So quit, and now CPT, future value, 7,139. Yeah. 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 Yeah, so 7,139 is going to be the answer for this question. All right. What's the present value of annuity that pays $28.50 at the beginning of the 3 months for 5 years? Okay. Assume interest rate is component is 8% component quarterly. Okay. All right. So this question is the present value. Okay, the present value question. So which kind of annuity is beginning is we do annuity every 3 months. Assume interest is component quarterly. Component quarterly means every 3 months component, and then the payment is done every 3 months. So it's going to be do simple annuity, right? Do simple annuity, and you're looking for the present value for this. Okay, so let's go to the calculator. Make sure it's the begin. Make sure it's still in begin. Clear everything. Clear work. Clear everything. Make sure everything's cleared here. So 28.50. 28.50 payment. Every 3 months for 5 years. So 4 payment per year multiplied by 5 years is going to be 20 payments total. So 20 payment total. 8% compounded quarterly. 8% going to be I over Y. So this is present value or future value? What's the present value? The future value is going to be 0. Yeah. And we want to know what's the present value, right? So, and now let's go to I over Y, P over Y, right? P over Y, C over Y, sorry. P over Y, payment per year. How many payment per year we have? It's going to be 4, right? And compounding frequency is going to be 4 as well, right? Because compound quality, okay? So it's out, and now CPT present value, 47,533, okay? 47,533. Okay. All right, so that's it. Any question, guys, so far? Because I'm going too fast on this, right? So because it's just an overview. Oh my God, there are 2 people in the waiting room. All right. All right. All right. All right, guys. If you come late to the class, you're missing a lot of part of the class. Okay. And as I said, this is basically a review session, and we are almost more than halfway to finish our review. So, and so if you have a question, as I said at the beginning of the class, if you have a question, just let me know. Otherwise, we're gonna continue with the review, and also make sure that you finish your test. You do the test by tomorrow evening, guys. Okay, tomorrow evening is the last day of your test. Okay, just make sure you do that. Okay, make sure you do that. Okay, so okay, so let me continue with that. Okay. All right, so yeah, so that's what we calculate, right? So it's just using the calculator. Using calculator make life much easier, right? So it's just okay, you can do that. Okay, Lance invested 3,500 at the beginning of every year for 8 years. Next software company that assured him an interest rate for 5.4% compound quarterly on his investment. What was the accumulated value of his investment? Okay, so that's the future value problem again. As the beginning of the every year means this is due annuity, right? And compounded quarterly. So it's compounded quarterly, compounded every 3 months, but the payment is done every year, right? So means that general, right? So due general. The due general annuity, right? So it's due general annuity again. And then let's do that. So due general annuity, since it's due annuity, we need to in calculator we need to set at the beginning. So let me just clear everything again. Make sure BGN is on top of your calculator, right? It means due annuity. You're working with due annuity. $2,500 invested as a payment for 8 years. So how many payments we have? 8 payments, right? Every year, so 8 payments is going to be a number of payments. 5.4% is going to be y over I over y. So this is a future value problem. So present value is going to be 0, right? So, and then we go to P over Y, C over Y. P over Y payment per year. How many payment per year I have? 1 payment per year. How many compounding? What's my compounding frequency? Compounding quarterly, right? So compounding frequency is going to be 4, right? So 4 is going to be compounding frequency. And quit. And CPT. Yeah, is that future value? Yeah, future value. Okay, 35,913, right? So 35,913 is going to be accumulated value. What was the interest earned over the period? So interest earned over the period means how much he paid total and how much he got at the end. So at the end he got this money from the bank, but how much did he pay total? In total he paid 8 payment of 3,500, right? 8 payment of 3,500 he just paid, right? So he paid $28,000, but he received 35,913 from bank because of the interest, right? So the interest is going to be that guy minus that guy, which is the future value for this, minus the money he put in the bank physically. So that's going to be the interest. Yeah. Any question, guys, so far? All right. So Rima inherited her husband's money, which provided her with $6,750 at the beginning of every month for 25 years. If the interest on the saving account was 4.8% compounded semi-annually, what was the total amount of money she inherited? Round your answer to the nearest $100. Okay, so all right. So in this case, first of all, which kind of annuity it is? Is beginning of every month, right? So it's going to be due annuity and compounded semi-annually, but it's every month, right? So it's going to be due general annuity. Okay. I'm sorry, guys. It's a due general annuity, right? It's a due because it's beginning of every month, and general because its compounding frequency is different than the payment period, right? Compounding period is different than the payment period. Okay, so due general annuity, and now we want to know what was the total amount of she inherited. So she inherited some money, and now she's getting money out of that money for 25 years, right? So at the beginning she has some money, and now she's getting money out of it. So it's not investment, right? So we're looking for as a present value. So it's a present value problem, guys. Okay. So let's do it in financial calculator again. So beginning means it's due annuity, right? So it's a begin. So let me clear everything. Make sure so it's a BGN is on top of your calculator, means it's due annuity. 6750 as a payment every month for 25 years. So it means 12 months a year multiplied by 25 years, 300 is going to be N, right? 12 is going to be n. 4.8% is the interest rate. So now let's go to, so as I said, it's the present value problem, right? So then at the end, you have 0 in the account, right? So you withdraw the money until it's finished, okay? 0 in the account. And now let's go to this P over Y, C over Y, right? P over Y, how many payment per year? 12 payment per year, right? So 12 payment per year. And C over Y, what's compounding frequency? Compound semi-annually, so 2 frequency. Okay, quit. And that's the present value problem, right? So 1.188 million and round it to nearest hundreds, 1.188300, right? So it's going to be the result. Yeah. Any question? All right, so let's do the next one. Andre obtained an 86,450 factory improvement loan from the bank at interest rate of 15% compounded monthly. What's the size of the month-end payment required to pay off the loan in 12 years? Okay, so now that's a different question. It's not future value and present value. It's a PMT problem, right? You want to know what's a PMT? What's a payment, right? So in this case, let's use a financial calculator, which is easier to do that, right? So so you have so obtain this guy as a present value, right? Obtain this loan from bank with this interest rate, and he has to pay it off in 12 years, and month's end payment. So it's going to be, this is month's end, right? So it's going to be ordinary annuity, and it's going to be monthly and the compounded monthly and the month's end, right? So it's going to ordinary simple annuity. This is ordinary simple annuity with the present value. So you have a present value, ordinary simple, right? So you want to know what's a PMT, okay? So let's go to financial calculator and calculate this. So let's clear everything first. That's ordinary annuity, guys. You have to get rid of that BGN on top of calculator. So second BGN, second and quit. Okay, so now you don't have anything on top of your calculator. So it means it's calculating the ordinary annuity. Okay, and now 86450 is going to be the present value, right? And now the future value is going to be 0, right? So you're going to pay it off at the end, right? So now I over Y is 15%. Month's end payment every month for 12 years, 12 by 12, right? 144, right? 144 is going to be 12 by 12, 144. 12 multiplied by 12 is going to, 12 multiplied by 12 is going to, sorry. What should I do here? Okay. All right, so 12 multiplied by 12 is equal to 144 n. Okay, so that's it. So now let's go to P over Y, C over Y. P over payment per year. How many payment per year you have? It's 12 payment per year. And what's compounding frequency? Compounding frequency is the same, 12, right? So quit. And now we wanna know what's the present, what's the payment, right? So we have PV, we have FV. We want to know what's the payment, CPT payment. 1297.5. Yes. See? Yeah. All right. After winning a lottery, $10,300 is deposited. Okay. So any question until now, guys? You see, using a financial calculator is very easy, right? So you can easily use the financial calculator to calculate all this basically calculations. So I recommend to use that in your test, but if you have time, I think it's good to also check the formula, see whether it matches with the formula. Okay, but just I leave it up to you guys. Okay. After winning a lottery, 10,300 is deposited into an account, earning interest at 3% compounded annually. Okay. What's the largest withdrawal which could be made at the beginning of each months from this account for the next 8 years. All right, so this is still okay. First of all, let's see which kind of annuity it is. Beginning of each month is going to do annuity and compound annually, but it's months, so it means that do general annuity, right? So is it present value problem or future value problem? It's a present value, right? 10,300 deposited, and then now you want to withdraw from it for the next 8 years. So it's 10,300 is the present value, okay? So the present value, future value is going to be 0. So let's do that in the financial calculator. First of all, it's due annuity, right? So it's beginning of each month. So I need to basically change it to begin first, okay? And now let me clear everything. 10,300 is going to be present value. Oops, sorry. 10,300 is going to be present value, right? Future value is going to be 0. I over Y is going to be 3%. N is going to be each month for this kind for 8 years. N is going to be 12 multiplied by 8, right? 12 multiplied by 8 is going to be 96, right? 96. And now P over Y, number of payments per year, it's going to be 12, right? Beginning of each month. 12 is fine. C over Y, compounded annually. C over Y is going to be 1, right? Quit CPT PMT minus 120 bucks. 120 bucks, okay? All right. Another question: What quarterly payment should Tyler pay in order to save 50,000 in 15 years if money can earn 10% compounded semi-annually? Okay. All right. So first of all, which annuity it is? It's a quarterly payment, so it doesn't say beginning or end. It's going to be end, right? So it's when it doesn't say whether it's beginning or end, it's going to be end, right? So it's going to be ordinary annuity. Whether is it simple or general? Paid every 3 months, but compounded every 6 months, right? So it's going to be general. So it's going to be ordinary general annuity, right? So since it's ordinary annuity, we have to go to financial calculator, immediately change that to ordinary, okay? Immediately change that to ordinary and come back, okay? So there is nothing there, okay? That's important. First thing you see it, immediately you go to financial calculator, set it to that mode, okay? If it's due, make it beginning. If it's ordinary, make it end, okay? Now we want to know whether it's a present value problem or future value problem. Okay, what quarterly payment should Tyler pay in order to save $50,000 in 15 years? So it's going to be future value problem, right? So it's going to be saving the money, paying the money to save $50,000 in 15 years. So it's going to be future value. So the future value is going to be $50,000, okay? So $50,000 is going to be future value. So present value is going to be 0 because it starts from 0, from scratch. He wants to save, right? So 10% compounded semi-annually, 10% this guy. And how many payments is that? Quarterly payment for 15 years. Quarterly payment every 3 months, right? So means 4 payments per year for 15 years. 4 multiplied by 15 is going to be 60. 60 is going to be the total number of payments. Now let's go to P over Y, C over Y. Payment per year, how many payments per year? It's going to be 4 payments per year, right? So 4 payment per year is going to be this. And what's the compounding frequency? It's semi-annually. 2 is compounding frequency. All right, come out. Now that everything's set, we go CPT PMT. 371 bucks. 371 bucks. Okay. That's the that's how we calculate this. Now before the end, okay? Total number of payments, okay? Total number of payments and number of years, okay? So let's solve some examples for that as well. Okay, so no questions so far, guys? Any questions so far? You see, it's very simple to use financial calculator, right? Any question, guys? All right, so what happened? Someone screamed. What happened?
Yeah, Professor, I have a doubt actually.
Priyanshi, I can't hear you. Your voice is cutting off. Priyanshi, I can't hear you. All right. All right. So let's continue until Priyanshi come back. Okay, so if money can earn 18% compounded monthly, so how long? Okay, so now the problem is how long. It's not payment, it's not future value, not present value. It's how long problem, right? So it's going to be n problem, I would say. So how long run up to the next payment period will it take for the funds in an RSP to grow to 385,000 based on annual year-end contribution of 3,200? Okay. All right, so first of all, we need to know which kind of annuity it is. So it's going to be okay. So annual year-end contribution. Okay, so it's going to be ordinary year-end contribution, right? Year-end contribution every year he contribute 3,200, right? So it's going to be annual year. It's going to be ordinary annuity. Is it general or is simple? Is general, right? Because contribute every year, but the interest rate is compounded monthly, right? Contribute every year, compounded monthly. So it means general. So it's going to be ordinary general annuity, right? So as soon as it's ordinary, I have to go back to calculator and set it to ordinary. Okay, yeah, it's already ordinary. It's already nothing on top of it. So if it's nothing on top of it, it means it's ordinary. Okay, so now let's do that here. So 18% is going to be 18% is going to be interest rate. Grow to 385,000. So it's a future value, right? It's a future value problem, guys. Okay. $385,000 is going to be $385,000 is going to be future value. So contribution every year, contribution 3,200. So 3,200. Make sure the sign is negative, right? Okay, so make sure the sign of payment is negative. It's negative, guys. Always payment sign is negative, okay? And present value is 0, right? And now we want to know what's n, right? So we don't know what's n, okay? So now we set PV, we set PMT, we set PF3, we set I over Y. We set all these 4. We want to know what's n, right? The only thing we have to set is P over Y, C over Y. P over Y, payment per year. How many payment per year you have? Only 1 payment per year, right? Annual year-end payment. So 1. C over Y, compounding frequency is 12, right? Compounding monthly, 12. Okay. And quit. Now we want to know what's n, right? CPTN. 17.91. 17.91 doesn't make any sense. It doesn't make any sense. So it has to be 18, right? So it has to be 18, right? So you want to know how many contribution was that, right? So 18. 1791 doesn't make any sense. So 18 contribution, 18 years, right? 18, and since you do every year contribution, it's going to be 18 years, right? So 18, and you do it every year, right? So every year, so it's going to be 18 years. All right, so here's another example. Oscar won the lottery of $38,000, and he deposited the money in an investment fund, earning 6.4% compounded quarterly. If he were to withdraw $2,000 at the beginning of every 3 months, how long would the money last in the fund? Okay. First of all, we need to know which kind of annuity it is. Okay, so it's beginning, right? So it's going to be due annuity, right? And every 3 months, okay? And 6.4% compound quarterly. So every 3 months compound quarterly means it's simple, right? So compounding frequency is going to be the same as your payment period, right? So it's going to be simple. So it's going to be do simple annuity, okay? So second thing we have to check whether it is a present value problem or future value problem. won a lottery 3,000 and deposited the money. So he earned, he won this money at the beginning, and deposited in the investment fund, and he's withdrawing from it. Okay, so that's the present value. There's a present value. There's a present value. He deposit in an investment, and he's withdrawing from it. Okay, so it means it's a present value problem. It's a present value, and at the end he doesn't have any money left, so it's going to be present value. Okay, so that's basically beginning, which is due. So as soon as we know there's a due annuity, we have to go to calculator and set it to due annuity. Yeah, set it to BGN, and now that's a present value problem. $38,000 present value. So future value is going to be 0. And how much is the payment? $2,000 a month, every 3 months payment. And I over Y is going to be 6.4. And P over Y, C over Y, P. Number of payment per year. How many payment per year you have? Okay, so it's 4 payment per year, right? 4 payment per year, and compounding frequency is going to be 6.4% compound quality. It's going to be 4 as well, right? So 4, and quit. Now CPTN. So 22.399. So round up to the next payment period. So it's going to be 23 payments. So 23 payments of quarterly payments, right? So it's going to be 20, 22, 23 withdrawals. So 23 withdrawal every 3 months, okay? So you have to divide this guy by compounding frequency in number of payment per year. If you divide this guy by number of payment per year, it's going to be 5.75 years, right? So 5.75 years doesn't make any sense. You want to know how many years and months it is, right? So you have to isolate that 75, multiply by 12 months, right? So 0.75 years is going to be 9 months. Okay, 5 years and 9 months. Yeah. Any question? All right. Okay, so one more example here. I think these are our last examples, so we can call it up soon. So Go Traveling invests $56,000 in an investment fund that's growing at 5.6% compound semi-annually. If Go Travel wants to withdraw $4,300 from this fund at the beginning of every month, how long will it take till the money lasts in the fund? Round up to the next payment period. Okay, so invested $56,000 and withdrawing from it beginning every month until it's finished. Okay, so this is the present value problem, right? So you invested and now withdraw from it. Okay, so that's a present value problem. And so which kind of annuity is this? Beginning, which is due annuity, every month, compounded semi-annually. So this is due general, right? So because every month, but this is semi-annually, right? So this is due general. It's a due general annuity. Okay. So now, if we go to financial calculator, begin. So make sure it's begin. It's already begin, so it's good. You don't need to change it to begin, BGN, right? Now, 56, as I said, $56,000 is going to be present value, right? $56,000 is going to be present value. Future value is going to be 0, right? So because at the end it doesn't have anything left. $4,300 is going to be negative sign. Make sure the sign is negative, guys. PMT. Now, and now 5.6% is your interest rate. P over Y, payment per year. How many payment per year is this? Beginning every month, right? So it's going to be 12 payment per year, right? So 12 payment per year. Compounding frequency, compounded semi-annually, right? So compounding frequency is going to be 2, right? So 2 is going to be compounding frequency, right? So get out. So I said everything, CPT and 13.39, okay? Now to next payment period, so it's going to be 14 payments, right? So 14 withdrawal. So 14 withdrawal of every month is going to be 14 months. It's going to be a year and 2 months, right? No, okay, so that's the other way. 14 withdrawal every month, right? You do 14 withdrawal every month. So 14 divided by, okay, so the other way you can do You say 14 withdrawal every month, it's going to be 14 months, it's going to be a year and 2 months, right? This is one way. The other way is 14 withdrawal divided by the number of payment per year. So you have 12 payment per year. It's going to be 14 divided by 12, 1.1666 years. And you keep 1 year, and the rest of it you multiply by 12 months to know how many months it is, right? So that's the best. That's a better way. That's a better way, because sometimes it's just not the months. Sometimes it's every 3 months, sometimes semi-annually. It's just better to divide the end by number of payment per year. Divide the end by the number of payment per year, and then you know how many years it's going to be in terms of a decimal and a fraction. You have a decimal number which has a real number and some fraction, and you multiply fraction by 12 months. So you get that. Okay. All right, guys, that's the end. So as I said, it's going to be short. This is going to be short session, because this is going to be short session because it's just an overview. Pranshi, you said you have a question, right? You have a question, Pranshi. Can you? You have a question? Still, you have a question, Pranshi? Okay, I can hear you. All right, guys. Yeah.
I have. Can you now?
Very hardly I can hear you, guys. I can hear you, Pranshi. Very hardly I can hear you. If you have 2 different
Check the
PMTs,
chat box.
Pranshi, I can't hear you. I cannot hear you, Pranshi. I cannot hear you. All right, so let me stop sharing. Okay, General Duanity, can you? Okay, so I don't want to take the class time. Okay, if it's I don't want to take the class time because we already finished this. So, but if it's important question you think is important for attention of everyone, you can just post your question in the chat box or email me, Gashi. I can't hear you, Gashi. I can't hear you. All right, you can email me your question, Gashi, and then don't take class time. Okay. Any question, guys? Any other question? Okay, so make sure that you do the test, guys. Tomorrow is the last day for the test. Make sure you do the test, and I wish you guys good luck. Okay. Make sure you do the test, and if you have any questions, just send me an email. Okay. All right, guys. I will call it off now. So, all right. You have a good day. Just make sure. Good luck with your exam as well. Okay. All right, guys. See you guys next week.
Thank you, sir.